Hello and welcome back. In section 1.2, we'll be looking at some of the basic functions, elementary functions, and transformations. So hopefully this part is mainly review from your college algebra days. So we'll just run through some of the basic functions that we're expecting that you sort of know how to sketch. So we'll start with the identity function. And it's called that just because whatever you put into it is what you get out of it. F of x equals x. Put it in a 0, get out of 0. Put it in a 1, get out of 1. Put it in a 2, get out of 2, etc. Put in a negative 10, get out of it a negative 10. Put in a negative 2, get out of it a negative 2. So this one is a nice, pretty line. So we have our arrows on the end, since that pattern will continue in both directions. So our domain no restrictions. Plug in a real number for your input, you'll get a real number for your output. Negative infinity to infinity if you like the interval notation. Same thing with the range. All the real numbers. Or if you like the interval notation, negative infinity to infinity. It can drop down forever, it can climb up forever. Doesn't skip anything. We have our friend the square function. So taking, that's why they refer to these sometimes as basic functions. We're only doing one thing each time. So square 0, you get a 0. 1 squared is 1. 2 squared, now we're at 4. So you can tell right away just from those first 3 points we're nonlinear. 3 squared is 9. 4 squared, 16. That would take us a little bit off the chart. Negative 1 quantity squared is 1. Negative 2 quantity squared is 4. Negative 3 quantity squared is 9. So this one, a nice smooth curve connecting all those nice neat corner points. They're referred to as lattice points. Just integer comma integer. So we can see our domain is the same as before. We'll just go with the interval notation. Our range, however, the lowest we can go here is 0. We do actually reach 0, so that gets a bracket, not a parent. So next up, our friend the cube function. F of x is x cubed. And then just think of doing that one thing to each of the basic functions. An input of 0, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed, we'd be all the way at 27 already. Negative 1 quantity cubed is negative 1, negative 2 quantity cubed is negative 8. So then we just go ahead and once again connect those up with a smooth curve, arrows on the end since that pattern does continue. So our domain and range on both of these would be negative infinity to infinity. I can go right forever, left forever. So domain, negative infinity to, that is an ugly infinity to infinity. And our range we can drop down forever, climb up forever. Also negative infinity to infinity. if we're talking about graphing in our usual xy plane, the square root function has a restricted domain then. F of x is the square root of x. So square root of 0 is 0, square root of 1 is 1. The next perfect square we have after that is 4. Square root of 4 is 2. Next perfect square after that is at 9. Square root of 9 is 3. And then I'd have to go all the way to 16 for our next nice, neat, pretty perfect square. Square root of a negative kicks us out of the real numbers. Remember what this plane is. These number lines are real number lines. Here's a vertical real number line. Here's a horizontal real number line. Square root of a negative is nowhere on a real number line. So this time our arrow is only on one side, not the other. We come to a screeching halt there. So our domain, I'll go down here so I'm not sort of covered there. We can go left as far as 0. We are allowed to plug in 0. Square root of 0 is 0. And we can go to the right forever. Same idea on the range. We can drop down as low as 0. We did reach 0. And we approach infinity. Just a couple more of the basic ones, and then we'll do a quick little review on translations. The cube root function, f of x, is the cube root of x. So notice we have the little subscript 3 in the crook of the radical. So cube root of x, and again, just on the basic functions, think what you would do to each input. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of, I'd have to go all the way to 8. Cube root of 8 is 2. And next I would have to go all the way out to 27, which takes us off the camera. So cube root of negative 1 is negative 1. Cube root of negative 8 is negative 2. So again, a nice smooth curve and arrows on the end because this pattern will continue in both directions. So odd index, you can take a negative as the radicand. Odd number of negatives will kick you over to a negative, so that one's okay. Even indices would kick us out of the real numbers. So domain and range, we can go left and right forever. We can go down and up forever. So negative infinity to infinity for both domain and range. And then our friend, the absolute value. F of x is the absolute value of x. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2, and so on. Absolute value of negative 1 is positive 1. Absolute value of negative 2 is positive 2. Absolute value of negative 3 is 3. Absolute value of negative 10 is 10, and so on. So absolute value, remember we're just looking at distance from 0. So this we have a pair of rays that meet at a 90-degree angle. So then our domain, we can go left and right forever. Our range, though, lowest value we can get is a 0. We do reach the 0, and we can increase forever. We can approach infinity. So hopefully those are some basic review ones, but it's important that you know all those properties going in. Then a little bit of review with shifting. So graph using shifting, reflecting, stretching, shrinking, also called compressing. So we'll just start with the shifting. So just a couple basic properties. Graph of y equals f of x plus k is the graph of y equals f of x. Shifted, and two cases. Up, absolute value k units when k is greater than 0. Down, absolute value of k units given if k is less than 0. Graph of y equals f of x minus h. Notice the minus h is inside of the grouping symbols. So this time we're shifted either left or right. So if it is a minus h, to the right, absolute value of h units. If it's a plus h, we're going to the right, absolute value of taking us to the left, absolute value of h units. So we work kind of backwards. Plus inside takes us in the negative direction. And if you think about it, just think what it would take to get a 0 on the inside. So let's just do a couple quick examples. So do y equals x squared plus 3. Using this method. And if we're doing the review on shifting, reflecting, etc., we're going to be sketching those by hand. I know you can all key them into a calculator. That's not the question. So here, y1, you just relate to what is the basic function that's going into it. This one would be the square function. So I'll put down points for 0, 0, 1, 1, 2, 4, and 3, 9. And that's sufficient on the right side of the origin. On the left side, we just have our mirror images, since this is an even function. And then once you have your basic function, then we just figure out, okay, well, what sort of, in this case, just shifting are we doing? The plus 3 is outside, so it's not an x plus 3 in parentheses with the square outside of the parentheses. We have the plus 3 outside, so that's just controlling up and down movement. So everybody is moving up 3 points. So each one of them just count up 3. So these guys were at a 9 already, so they would be all the way up at 12. That'd be about here, but it is technically off of our graph. So again, just a smooth curve connecting things up. So that will be our Y2. So you want to show the original and show what happens when you do the shifting. Of course, we get to play with some where we have both kinds of shifting happening in the same one. So we'll try maybe Y is the cube root of, do X minus 1 plus 5. So our first part of this, we're going to just look at the basic function. Y is the cube root of X. That'll be our Y1, and we'll do that, I guess, in red. So cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2, cube root of negative 1 is negative 1, cube root of negative 8 is negative 2. So the basic points on the negative 10 to 10 grid you should know for all of the basic functions and be able to plot those fairly quickly. And I am looking for the points to be on there, not just sort of some students will give me just a basic shape with no points on it. I do want the points to be on it. All of the shifting can be handled in one step. So this one is just a two-step. So the minus 1 inside will take us to the right one. Plus 5 outside will take us up 5. So each point I'll count right 1 and up 1, 2, 3, 4, 5. Right 1, up 5. Right 1, up 5. And same with our Q3 buddies. So right 1, up 5. And right 1, up 5. And then again, nice smooth curve, arrows on the end. Alright, so let me have you all try one out. And again, trying to simulate what we'll be doing on quizzes and tests. You'll be doing it without the graphing calculator in your hand on the sketching part. So you're going to try out f of x is the, let's see, we'll do x minus 3 quantity cubed plus 2. So go ahead and pause the video, see if you can do the, this one should be 2 stages of your graph. Okay, welcome back. So our basic function, this is most closely related to y equals x cubed. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. Negative 1 quantity cubed is negative 1, negative 2 quantity cubed is negative 8. And then we have our smooth curve connecting those 5 points. 3 points is insufficient for this. You definitely need all 5. Then our next would really just include the shifting. So we're moving to the right 3 and up 2. So each one of these just count to the right 1, 2, 3 and up 1, 2. Right 3, up 2, right 1, 2, 3, up 1, 2, and right 1, 2, 3, up 1, 2, and so on. Okay, so then we'll take a look at reflecting, stretching, and compressing. Really, all of those are going to be under the same hat. Those are all involving multiplication. So let's see. So we'll look at do f of x is -1/2 of x minus 3 quantity squared plus 2. So this one, because we have some multiplication involved, this factor times our x minus 3 squared, this is going to end up being 3 stages. So we'll have the original, we'll have what the -1/2 does, and then we take that graph and do any shifting we need to do. So y1 is just going to be this one. Hopefully you notice the basic of it is the x squared. y1 is x squared. Your equations do need 2 sides. Occasionally we'll have just the students have just x squared written, and that doesn't really mean anything in an xy plane. Okay, so 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And unfortunately my ink, 1, 2, there's my 3. And our points across the way there. So -1 quantity squared is 1, -2 quantity squared is 4, -3 quantity squared is positive 9. So I'll put my little key on there. And there's our first stage. So here is the second stage, -1/2 times our x squared. So notice x squared was equal to our old y value. So basically think of this as doing -1/2 times our old y. So 0 times -1/2 is still 0, but 1 times -1/2 is -1/2. 4 times -1/2 is -2. Nine times -1/2, -4.5. 1, 2, 3, 4.5. And its partner 1, 2, 3 units this way as well. So the negative flipped it over. There's the reflection part. And notice that it's also being vertically compressed. It's being smashed down vertically. If I went one more space out, 4 squared would have been 16. -1/2 of 16 is -8. And I would have been down here at -8 as well. That would have also fit. So we have a much wider parabola. Negative just flipped it over. 1/2 is smaller than 1 in absolute value. It will compress it. Had this been bigger than 1 in absolute value, it would have been a vertical stretch. And then I invite you to finish this problem off I'll just leave you with the hint that you're always working off of the last stage. So the final version, you're going to take the blue points, shift them right 3, up 2. Alright, so I'm going to give you one where you can sort of practice all the stuff that we got to play with. So you're going to try out f of x, negative 1/3 of the cube root of x plus 2 minus 4. So see if you can do the 3 stages that are going to be required for that. Go ahead and pause the video, give it a try, unpause it when you're done. Okay, welcome back. Okay, nice and bold on there. Okay, so your first stage should have been just y1 equals cube root of x. I'll do that one in blue was the one that my fingers grabbed first, so blue it is. All right, cube root of 0 is 0, cube root of 1 is 1, and we go all the way out to 8. Cube root of 8 is 2 for our next lattice point. Cube root of negative 1 is negative 1, cube root of negative 8 is negative 2, and those are the 5 points that we can fit for the basic cube root function on the negative 10 to 10 grid. Okay, so then next up, if there's any sort of multiplication, multiplication comes before adding and subtracting. So we'll take care of that negative 1/3 next. So cube root of x was our old y value, so negative 1/3 times our old y value. 0 times negative 1/3 is still 0. 1 times negative 1/3 is negative 1/3. 2 times negative 1/3 is negative 2/3. Negative 1 times negative 1/3 is positive 1/3. Negative 2 times negative 1/3 is positive 2/3. So we've flipped it and pretty significantly compressed it as well. So then your last stage would be the entire f of x. So we take what we did before and shift it left 2, and minus 4 will drop us down 4. So, and again, that's happening only to the red points. All of the red points, left 2, down 4. This red point, left 1, 2, down 1, 2, 3, 4. Left 1, 2, down 1, 2, 3, and 4. Left 1, 2, down 1, 2, 3, and 4. And left 1, 2, and down 1, 2, 3, and 4. So same shape. Just compressed it and shifted it. So 3 stages, 1, 2, 3 on there. Okay, so some problems I would recommend out of section 1-2. I would recommend 1 to 41 on the odds, and 55 to 59 also on the odds. And I'll also put up sort of the publisher's sort of basic default assignment for those of you that are the My Math Lab fans as well. If you have any questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.